Hello everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called longest repeating character replacement. So we were given a string s and an integer k. We can choose any character of the string to change it to another character, and we can at most perform this operation for k times. We're going to return the length of the longest substring containing the same letter after the operation. Let's take a look at an example here. We have AB and k equals to 2, which means we can change at most 2 characters to another character. So now we change 2 B's to 2 A's, and then we got 4 A's. So the longest substring we get is 4. And here's a better example here. We have BBA, and k equals to 1. And we can change this B to A to get a result of 4 A's, or we can change this A to B to get a result of 4 B's. In either result, we get a longest substring of length 4. Okay, so how do we approach this problem? Let's take it over here. Let's say BB, okay? So if we have a sliding window, and okay, let me see. Let's say the k equals to 2, okay? If we have a window that goes from the first character of the string and goes all the way to the last, and we maintain a sliding window at this time, and we check whether if it's invalid or not, and we change all the different characters within the k. Okay, let's see. We have this, and we have only a letter A, which is okay. And now we have 2 A's, which is okay. And we have another one B. So it should be okay because we have 2 characters to change. And another one, we got A, okay. And here, it's still valid because we used the last chance of changing the character. Okay, and once the right boundary goes here, it becomes invalid because we have 3 B's and 3 A's, and it needs 3 operations to change the character. But we only have 2, right? So now if it's invalid, we move the left pointer to the right to see if it's valid. So now we have 2 A's and 3 B's, and we can change 2 A's to B's. So now we get a valid answer. And we can do this until R goes to the rightmost part of the string, and we end this logic. So what we need to do here, I think there are several things here. The first thing is to set up a sliding window, okay, and with a left pointer and a right pointer. And the second thing is to check if it's valid along the way. And third, we need to keep a frequency map for each characters. And fourth, we need to update the longest substring length at each step. Okay, so let's try to code it out. To set up a sliding window, we need a left pointer and we need a right pointer. So since the right pointer goes all the way down, we can use a for loop for the right pointer. R is less than length. Okay, so before that, we need to set up a frequency map for all the characters there, and we need a result for the longest, for the length of the longest substring. Anything else we need? Oh yes, we probably need a max frequency here so that we can check if it's valid with the max frequency within each sliding window. Let's say if the max frequency here is 3, right? And the max frequency here is also 3. And that matters because we know the max frequency of one character. We know how many other characters we need to operate on. Let's say if we have here maximum frequency of 3, but we have 6 characters, that means we have 3 more characters to take care of, but we have only 2 Ks here. So this would be an invalid window. Okay, so we need a max frequency and set it to 0. Okay, so let's do the main logic. When right pointer moves, at first the right pointer points to here, the first character. So once it moves here, we will record it in our frequency map. So s.character at r minus a plus plus, and we will update the max frequency at this time. And it should be the frequency map. Okay? So once we have the maximum frequency, we have to check whether it's valid or not. How do we check it? We check with the length of our existing sliding window, and we subtract the maximum frequency of the same character. If this result is less than or equal to k, then it should be valid. Okay, so yeah, that's it. If it's invalid, what do? We move let's write it down here. So if invalid, we decrease the frequency of left character and move left character to the right. Okay, so if it's invalid, we're going to frequency map, this time left minus minus, and move left pointer to the right. Okay, along the way we're going to update the longest substring length at each step. So result will be maximum of result, or right minus left plus 1. Okay, and this should give us the final result of the longest substring. Let's see if it works. Okay. Okay, I think it passed the initial check. The logic should be right. Let's take a look at the complexities. So time complexity wise, we only loop through the string for once, so it should be O of n. And space complexity, we only have a frequency map, which is considered to be O1. And any other stuff? Yeah, not really. Probably just this one. So we can either say it's O1 or maybe O unique characters, because yeah, we're saving it there. So that should be the answer. Let me delete all these and submit it. Let's say it's just O1, okay, because it's fixed size. Okay, that passed all the test cases. Thank you so much for watching. I'll see you in our next video.